Okay, this DeltaMath lesson is going to help you to see some different things about graphs, review some of the other things we've done in our Big Ideas book. So the first thing we're going to be looking at is tables and determining if they're linear or not. Remember, linear means it has a constant rate of change. So the rate of change technically is the change in x divided by the change in y. So x is going up by 1, y is going up by 3. So this has a rate of change of 3 because 3 divided by 1 is 3. And then 3 divided by 1 is 3 again. And then actually this is down 3. So -3, -3, and then this is going down 3. So -3 divided by 1. It looks like the rate of change stays the same for the entire table. So I think A is linear. Just to show you one of the ones that would not be linear, this one is going down by 2. And then it goes down by 1, and then it goes down by 2 again. This is not linear because it does not have a constant rate of change. Technically now on this one, the rate of change would be a -2 divided by 2 since x is going up by 2, so it's a -1, and then that's a 2, so that would be a -1/2. But you really don't have to worry about the x values as long as the x values are changing at a constant rate. It's when you start getting tables like this where the x values don't change at a constant rate that you have to pay more attention to those. For example, on this one, the y's are changing by going up by 2, and the x's are going up by 2, so that rate of change is 1. On this one, this is going up by 2, and this is going up by 3, so my rate of change is a 2/3. So it's always the y change divided by the x change. So that's why you have to look at both the x and the y, because the rate of change is not just the y value, because if the x is changing by a funny rate, not a steady rate, it's that you're going to have to be careful to do the y divided by the x. Let's try one more of these together. Okay, same thing, but they gave me ordered pairs instead of a table. So I'm still going to look at my y change and my x change. So between my first 2 points, I have the y is changing, going down by 3, while the x goes up by 1. So that rate of change is -3, because -3 divided by 1 is -3. For the next one, the y is going down by 3, while the x goes up by 1. So that's still a -3. And then this one, the y is going down by 3, while the x is going up by 1. So that's a -3. That makes me feel like that A is my answer for a linear function. We'll look at one of the others, maybe D, just to show you what something not linear would look like. In this case, my y is going down by 3, while my x is going up by 6. So my rate of change is -3/6, which reduces to -1/2. -3/6 would reduce to -1/2. In this case, my x is still going down by 3. My y is going down by 3, but my x is going up by 4. So this next rate of change would be -3/4, which is not the same as -1/2. And on this one, my y is changing by 1, and my x is changing by going down by 1, while my x is going up by 2. So that one is a -1/2. So it turns out these two do match, but since they don't all match, it's not a linear function. The only way to confirm it's a linear function, you do have to make sure that the change between any 2 rows on the table or any 2 adjacent ordered pairs is consistent. So since I have this 3/4 here, this one is not linear. And if you did B and C, you would discover they are not linear as well. Talking about where it is both increasing and linear. On these, we're looking for graphs where they are increasing and linear. Linear means a straight line. Increasing means going up as you go from left to right. So this part here is in a straight line and going up. So I need to look at the x values for this part. It starts at -9, and this piece of the graph stops at -4. So the piece I'm looking for will be the one between -9 and -4. Let's go ahead and try looking for that answer. Between -9 and -4 is an answer. If I pick that answer, notice when I get it right, it explains to me, it does a good job of highlighting and showing you that when you pick between -9 and 4, it's showing you that part of the graph there. So that is the part that is increasing and linear. We'll do one more if we have time. On this one, we're looking for the part that's between -5 and -9. So graph that, starting at 5 to 9. and that part would be going up and linear, so I'd be looking for